Recording has started.
So these two problems here are similar to the ones we did yesterday. First one starts out as feet, and we want it to be feet, inches, and we're going to 16ths we're asked for here. So we're going to pull the 4 off of that and keep it as 4 whole feet. So we just have the 0.731 feet. Now I'm going to do it right on the calculator here. To turn it into inches, I'm just going to do times 12. So that's 8.772 inches. I'm going to take the 8 for my whole inches. So on the calculator, I just subtract 8 and I keep the decimal in the calculator. Since I'm turning it to 16ths, I'm going to multiply by 16. Giving me 12.3. That's between 12 and 13. It is closer to 12. So 12/16, which reduces to 3/4 of an inch. So to the nearest 16th of an inch, that is 4 feet, 8 3/4 inches. Number 2 here, there's a step we have to do to start with, and that's going to be to divide. We're going to take that 211.463. It's in inches. We're going to turn it into feet, so we're just going to divide by 12. Now that's an ugly number, but it's telling us we have 17 whole feet. Now on the calculator, I'm going to subtract the 17 just to leave the decimal in there. And I'm going to turn that back into inches, so times 12. Now if we did everything correctly, that decimal should be familiar. That 0.463 should be back to the decimal we had before. It's the 7 whole inches that I'm concerned about. I'm going to take the 7 off of there. On the calculator, I'm just going to subtract 7 to get rid of the whole inches, leaving that decimal of 0.463 in there. Now I need to make that into 16ths, so I'm going to just times 16. That is 7.4. That's between 7 and 8. It's slightly closer to 7, so that's just 7/16. So 17 foot, 7 7/16 inches. Well, a couple of the questions yesterday went the other direction. If I give you something as feet, inches, and a fraction, can we convert the decimal inches? So let's convert. If I give you 8 feet, 3 11/16 inches, convert that and convert 47 3/16 inches. Convert each of those to decimal, actually not decimal inches, decimal feet, I should say, is what we want them converted to. I'll give you a minute or so, then we'll go over those. So we have to work this backwards to get to decimal feet. So I start out with my fraction of an inch. If I have a fraction of an inch, I'm just going to divide that to make it a decimal. 11/16 will be 11 divided by 16. So I have that 0.6875. Now I have to add my whole inches to that. So it's become 3.6875. So on the calculator, I would just add 3. I've got decimal inches, but I got to add that to the feet. So to convert that into feet, I'm going to divide by 12. 0.3073. And of course, I just add my 8 feet to that. That's 8.3073 feet. Yes, that is rounded because that decimal goes on forever. It's a repeating decimal once it gets up to the fourth or the fifth or sixth, actually the seventh decimal place there. But we're rounding it to 4 decimal places here. So to 4 decimal places, that is 8.3073 feet. Number 2 is actually a little bit easier. I'm just going to start with my fraction of an inch, 3/16. 3 divided by 16 gives me 0.1875. I include my 47 with that, so I'm just going to add 47. That's everything, but that's decimal inches. I want to make it decimal feet, so I'm going to divide by 12. So 3.9323 feet. Again, the 4 decimal places. These are processes that you're going to have to be able to do. Any sort of calculating on the job site, you're going to probably get your answer in decimal feet or decimal inches, and you're going to have to be able to convert it to the 16th or the 8th or whatever unit you're using. And the other way around as well. You're going to have to take those dimensions that are given to feet, inches, and 16ths, and to do anything with them, you're most likely going to want to convert them into decimal feet or decimal inches to calculate with. So have you guys, with Chris, have you guys gone over board feet yet? Give me a nod or a thumbs up if you have.
A little bit.
A little bit? Okay. A board foot. The technical definition of a board foot is 1 square foot that is 1 inch thick. So that means we have 1 foot by 1 foot by 1 inch thick. That's a board foot. The easiest way to deal with a board foot, however, is to just find its flat out volume in inches. So our 1 foot is going to be 12 inches in each direction. So our volume of this is 12 inches by 12 inches by 1 inch, which is 144 cubic inches. So that is often the modern version of a board foot, is used as simply 1 board foot, 1 BDFT is 144 cubic inches. Now the biggest question is if we want to go with nominal or actual. If you are purchasing lumber, they generally go with nominal dimensions. So let's say you are buying a 2x4. Even though we know it's only really 1.5 inches by 3.5 inches, we're using nominal dimensions, so 2 inches by 4 inches by 8 feet long. Well, first I'm going to convert that 8 feet into 96 inches. So the volume of that is 2 inches by 4 inches by 96 inches. Giving us 768 cubic inches of volume. So for board feet, I'll do the formal conversion here. Do our 768 cubic inches over 1 times 144 cubic inches in 1 board foot. So the cubic inches cancel out. We got 768 divided by 144. Give us 5.33. That is 5 1/3 board feet for that 2x4 by 8 foot long. Now, some lumber is purchased by the linear foot. So 2x4 by 8 feet long could be purchased in one of two ways. We could say that we're going to buy it at 53 cents per linear foot, which is just a foot of length. Or we could say we're going to buy it at 76 cents per board foot. We need to figure out which would be cheaper. Well, the price for the per linear foot, all we care about is that length of 8 feet. So we would take that 0.53 times 8. We get $4.24. That was a ridiculous price a year ago. It's actually pretty cheap right now. For the 0.76, the 76 cents per board foot, we just figured out that it was 5 1/3 or 5.33 board feet. So we do 0.76 times 5.33. We get $4.05. So it is slightly cheaper to buy it at the 76 cents per board foot than at the 53 cents per linear foot. This happens often enough, this comparison happens often enough, that we come up with a conversion factor. And the conversion factor we use is between linear feet and board feet. So we figure out how many board feet is in 1 linear foot of lumber. So let's look at that 2x4 again. So we're looking at a piece that is 2 inches. Oops, draw that very well. 2 inches by 4 inches by 1 foot long. So we're going, that's the linear foot. So this is 1 foot or 12 inches long. Well, that is, if we multiply that all up, a volume, 2 times 4 times 12, 96 cubic inches. So 1 linear foot equals 96 cubic inches. Well, 96 cubic inches has to be converted to board feet. 144 cubic inches per 1 board foot. 96 divided by 144 is 0.67. Board feet. So 1 linear foot here is equal to 0.67 board feet of that lumber. That's an important conversion factor. Often we see it written as 0.67 board feet per linear feet as a rate like that. But it's really an equivalency. Just like our measurement conversions we've been doing, we can use that to convert a measurement. I know that that is the constant for all 2x4s. It is 1 board foot equals 0.67, or 1 linear foot equals 0.67 board feet. So if I need 27 2x4 by 8 foot. If I want to know the board feet of that, I can find my linear feet. That's just going to be the 27 boards times 8 foot each. 27 times 8 gives us 216 feet. That's linear feet. If I want to convert that now into board feet, I know that 1 linear foot is 0.67 board feet. So the feet cancel out. It's just 216 times 0.67, giving me 144.72 board feet. Why is this a useful calculation? Well, there's a lot of reasons why it could be a useful calculation. One of them that I've used it for actually quite a bit is finding the linear feet of board required to do a deck. So let's say I'm going to do this deck or porch, whatever. We're going to use 2-inch by 6-inch tongue and groove. That means it's going to fit tight together. We are going to go down to its nominal dimensions. It's going to be 1.5 inch by 5.5 inch. Our porch here that we're going to do is going to be, let's go 16 feet by 28 feet long. To find the board feet, of an area like this, it is simply the area in square feet. Remember we said a board foot is 1 square foot that's 1 inch thick. We find the area in square feet times the thickness in inches. So this area, 16 by 28, is 448 square feet. The number of board feet then is going to be that area, 448 square feet, times the thickness of 1.5 inches. 448 times 1.5 gives us 672 board feet. Well, that's board feet. Well, how do we use that to find our linear feet? Well, we come back here, we're going to find that board feet per linear foot using those actual dimensions. When we install it, it's going to be the actual dimension that covers, not the nominal dimension. So our 1 linear foot of this pretend that looks like tongue and groove. This is 1.5 inches. 5.5 inches is going to go from here to here. So that's the coverage. So it's not including the spline. By 12 inches. So that volume is 1.5. 5.5 times 12. Or 99 cubic inches. So I'm going to convert that into board feet. It takes 144 cubic inches to make 1 board foot. which is 99 divided by 144, giving us 0.6875. That is board feet per linear foot. So what that's saying is 1 linear foot for this lumber equals 0.67 or 6875 board feet. So now we can go back to the fact that we calculated that we need 672 board feet. And we're going to figure out how many linear feet that is. We're going to put board feet on bottom so that they cancel out. That's 0.6875 board feet equal to 1 linear foot. So the board feet cancel out. This is 672 divided by the 0.6875. Meaning it's 977 and a half. We're going to round that to. Linear feet of lumber. Now that, of course, is not allowing for waste. You'll notice this deck was modular. I don't know if you guys have discussed the idea of modular yet, but modular is just making your dimensions so that you have as little waste as possible. Like making a 28-foot deck, that's a 4-foot increment. So pretty much, an 8-footer, a 12-footer, a 16-footer are going to fit on there with no waste. Typically what we'll do is if we're going to have a 1/4-inch overhang or whatever our overhang lip is going to be on the edge, we will shrink the frame slightly. I would actually make it 27 feet, 11 and a half inches on the frame so that you had that 1/4 inch to overlap or to overhang on the ends. So that it's all built in. We don't have to worry about cutting them to be that extra length. So then you end up with basically no waste by making it modular. Whatever you take, let's say you're going to use 20 footers for this. You put a 20-footer here, you have 8 feet left. Well, you take the next 12 feet, you put that 12 feet here. Use that up, you got 16 feet, you're going to have 4 feet left. So you put 4 feet here. 20-footer goes to 24, you use 4, you've got 16. So you can use whatever you cut off of one end, you can use to start at the other end, and it will be, as long as you're using either a 2-foot or a 16-inch spacing, it will be on the spacing. There won't be any, you may have to shave a little bit off of it to make it fit, but there won't be a lot of excessive waste other than just a sliver here and there. So I might ask, find the amount, the linear feet of 5/4 by 5.5 inch decking needed for 12-foot by 36-foot deck. And I'm going to have you allow 15% for waste. So what we basically have here is a 12 by 36 deck. Let's figure out the total number of board feet needed for that deck. So the board feet is going to be the area in square feet. That's 12 feet times 36 feet, which is, what is that, 432? It is 432 square feet. That's our area. So our board feet, again, is our area in square feet, the 432 square feet, times our thickness. Now our thickness here it's 1.25 inches or 5 quarters. I'm just going to do a 5/4 inch. And it has to be, our thickness has to be in inches. So we do 432 times 5 divided by 4. That's 5 quarters. Giving us 540 board feet of lumber. Now for 5/4, I know the edges of 5/4 are rounded, but for our purposes, we don't care. We're just going to go 5/4 by 5.5 by 1 foot by 12 inches. We're going to find the volume of that. It's 5/4 times 5.5, 12. Giving us 82.5 cubic inches. We're going to convert that 82.5 cubic inches into board feet. $82.5 divided by 144 is 0.5729 board feet. So 1 linear foot equals 0.5729 board feet. So again, we're going to take our board footage from our deck, 540 board feet, put it over 1, and we're going to use this as a conversion factor. Board feet are going to go on bottom, so it'll be 0.5729 board feet, 1 linear foot. So the board feet will cancel out. It's 540 divided by 0.5729, giving us 942.55 linear feet. Now it's said to add 15% for waste. Easiest way for us to add waste is to just multiply 15%, remember, is 100 plus 15. We're multiplying by 1.15. Look at the 942.55 times 1.15. Gives us 1,083.93, so 1,000. We're going to round that just to 1,084 feet of 5/4 decking we would use on that. Now that 15% waste factor is actually quite high there because that is a modular deck. That was 36 feet long. Chances are there's not going to be a lot of waste there, but we'll put the 15 feet in to account for crooked boards or bad cracked or knotted boards or whatever. Some people use a set formula for just a percentage of your flooring to account for railings or anything like that you might use deck plank for. There's all sorts of different factors you can account for. But that's just some of the basics of how to calculate with the board feet and then use them to actually find your linear foot for an estimate. I've done a lot of decks in my day. Calculating out the amount of deck plank needed is a real pain if you're going to try to sit down and sketch it out or whatever. Using the board feet and going through the board feet makes it way quicker to figure out what your linear feet of 5/4 deck plank is that you're going to need. So from a couple weeks ago, you had that packet. It is the Clayton High School packet. We did a little bit out of it yesterday. Towards the back of that packet, there's a section on board measure. I would just like you to look through that section of the packet. There are some problems at the end of the packet for you to look over and to test your knowledge. Like I said, it's a handy skill. I know a lot of contractors that don't use board feet anymore. Board feet comes in mostly now if you're in cabinet making and furniture making, because your hardwoods, your more attractive species of lumber, your rough cut lumber is going to be sold in board feet for the most part. But it's still a handy skill to have. Like I said, I know a lot of rough carpenters that don't use board feet at all, but it's very helpful if you do. With that, I'm going to give you guys an easy day today. I felt like I was pretty hard on you last week with all the quizzes. Remember, there's a quiz out there, that quiz 1011, that I gave you till Friday on. So make sure you're working on that. Remember, I told you to assume 8-foot high flat ceilings for the volume. Even though it's 9-foot high on the outside, remember that's floor thickness as well. So the actual ceiling height on the inside is 8 feet. Anybody have any questions? Okay, well, I'll let you guys get started on your homework.